well, there are like 3 or so space rocks for Mars. They may have broken into multiple pieces on reaching Earth, but so some of the surface features of Mars. Mars has quite a few craters. It has more than Earth and Venus, but fewer than Mercury and the Moon, sort of in between. Because Mercury and the Moon don't have atmospheres, so they basically can't. They don't have any real significant erosion processes. While Mars does have some erosion, it's got wind, it's got enough atmosphere to have wind and things like that going on. So craters can get worn down, and there's enough atmosphere to affect incoming objects. There are volcanoes. There are massive volcanoes on Mars. They're much bigger than the ones on Earth. In fact, the biggest volcano in the solar system is on Mars. And there are canyons that are tectonic features. They're not like canyons on Earth carved by water. Primarily canyons on Earth are carved by water. The biggest canyons on Mars are actually like caused by, they're like rips in the crust of Mars. They would stretch across the US. But there is evidence of flowing water. There's like river channels and things like that. So here's an example. Olympus Mons is the largest volcano in the solar system. It's 3 times the height of Mount Everest. It's comparable to the size of Pennsylvania, New York, and New Jersey combined as a reference. So this is Olympus Mons. This is Olympus Mons overlaid over, several states. It's also about the same size as France. Near Olympus Mons is what's called the Tharsis region. It's a hotspot region on Mars, like Hawaii is on Earth. The entire region bulges up by 7 kilometers, and the giant canyon is near the Tharsis region. And so it's thought that maybe the bulging of the Tharsis region is what caused the tear that formed the giant canyon. So that's the Valles Marineris. It's a 4,000 kilometer long canyon. It's much larger than the Grand Canyon on Earth. It's 5 times longer and 4 times deeper. And it was created by a different process. The Grand Canyon on Earth was carved by the Colorado River over time as it eroded downwards through the uplifted Colorado Plateau. The Valles Marineris appears to be a tear caused by, something pulling on the crust here. So it's a tectonic feature. It's similar to a rift valley on Earth. So you can see rift valleys in places like Iceland, in Eastern Africa. There's the big East African Rift Valley. So it's not caused, on Earth, rift valleys are caused by plates moving apart, but Mars cooled off too fast for plates to form. But the Tharsis region is to the left of this, so it's perhaps the cause of the rift. So here's the Tharsis bulge, and here's the Valles Marineris. They're close to each other, so they might be related. So the Tharsis bulge is the size of North America. It rises nearly 10 kilometers above its surroundings, and it has minimal cratering and is the youngest surface on Mars. So Mars had active volcanism that makes the surface, that area, there's several volcanoes on the Tharsis bulge. The northern hemisphere of Mars is rolling volcanic terrain. The southern hemisphere, however, is heavily cratered highlands, and the altitude is about 5 kilometers above the northern. It's thought that maybe there was a massive impact towards the northern end of Mars, which caused that whole area to be depressed and the southern side to be pushed out. The assumption is the northern surface is younger than the southern. This means the northern hemisphere must have been lowered in elevation and then flooded with lava. So one of the theories for what caused that is a massive impact hitting the northern hemisphere of Mars. So here you can see southern hemisphere is much more mountainous and cratered in the highlands. The northern hemisphere is lower and smoother. There's no evidence of plate tectonics. Here's Olympus Mons, the biggest volcano. There's the Tharsis Bulge, the Valles Marineris. Here's Viking 1, Pathfinder, the Phoenix Lander, Viking 2, Curiosities over here, Opportunities over here, Spirits over here. This map was made before Perseverance landed, so I can't tell you off the top of my head where Perseverance is. But it is in a rockier area than Opportunity is. So among the things that Mars has, it has the biggest volcano in the solar system, Olympus Mons, which is 700 kilometers in diameter at its base. It's 25 kilometers high. It has a caldera 80 kilometers in diameter. And 4 other Martian volcanoes are only slightly smaller. It's like a massive, massive version of the Hawaiian volcanoes. It's a giant shield volcano. So it's not super steep because it's made of thinner, more easily flowing lava, but it gets really big. And impact craters less than about 5 kilometers across have been eroded away. Mars has lots of wind and dust, which can wear away smaller craters. An analysis of craters allow us to estimate the age of the surface. So, for example, the crater on the right here shows ejecta that may have been liquefied by the impact that created the crater. There are some images of the surface of Mars. This is from Viking. This is the Mars rover Curiosity taking a picture of itself. Mars is very red. Who's sun in? Because the surface dust has lots of iron oxide in it, rust. So, Mars is the color red because of the iron oxide in it. It's actually a similar reason to why our blood is red and why rust is red. It's the same thing, iron, oxidized iron. And yeah, so this is Curiosity taking a picture of itself. Which, while amusing, is also actually helpful because you can use it to see if anything is wrong on top. Anything's getting messed with. This is the landscape near the North Polar Cap by the Phoenix Lander. One of the things the Phoenix Lander was able to do was determine that there was permafrost on Mars. It dug into the soil and found a layer of ice. So that's ice exposed by digging into the soil. And this was near the Phoenix Lander was near the North Polar Cap. The atmosphere of Mars is very thin. It's less than 1% of the thickness of Earth's atmosphere. It's mostly carbon dioxide, about 95%. With a bit of nitrogen and a bit of argon. There are high winds and massive dust storms. The high winds will pick up dust from the surface, and this will result in planet-wide dust storms. And in fact, the Opportunity rover, its mission ended after a dust storm in 2018 because basically it lost power. It was without power for long enough that it finally couldn't restart. So one of the problems on Mars for electronics is you have to keep them warm. So you need a certain amount of power for things to just keep working. And so one of the things that I was worried about were the solar panels getting covered with dust. Turned out they thought the dust storms were going to be a real problem for this, but they turned out to be an advantage because the dust storms would actually clean off the accumulated dust on the solar panels of things like rovers. But the Opportunity, rover had been running for so long that it basically was in a long enough dust storm that it wasn't able to restart after the dust storm. So you can get planet-wide dust storms like this. So this is a dust storm covering the entire planet. Mars has 2 moons. These are Phobos and Deimos. Phobos is in fact so close to Mars, it's only 6,000 kilometers from the surface, and it orbits faster than Mars rotates, and it will eventually be torn apart by tidal forces. It's within the limit where tidal forces will tear apart objects. And so it'll be gone in maybe tens of millions of years. There's a weird theory that maybe Phobos gets torn apart and recombines over time, but I don't know how well supported that theory is. Deimos is the smaller of the 2 moons. It's about 12 kilometers across. And it's thought that maybe they're asteroids captured by Mars. They're small and irregularly shaped. Please make sure you sun in. So Phobos, this is Phobos. And this is Deimos. It's thought that they're asteroids possibly captured by Mars. So Mars has been explored by a large number of spacecraft. It shows large volcanoes and canyons on its surface. And the atmosphere of Mars is very thin and primarily composed of carbon dioxide. And there's 2 small moons that are perhaps Castor asteroids. Now, one of the most interesting things about Mars is that there's evidence that there used to be water on Mars. And there's currently frozen water, there's solid water on Mars. The polar caps of Mars have water ice in them. And then they change over the year with a layer of carbon dioxide ice. There's also permafrost beneath the Martian soil. So this is permafrost, this is frozen water, and over time it is sublimating away once it is exposed, because the air pressure is so low that ice goes directly into water vapor. It doesn't become liquid water in between. There's no liquid water on Mars. The atmospheric pressure is too low, it sublimates directly from solid to gas. There's maybe some super thick brine oozing out of the sides of craters, but it's not certain if that's actually the case. So, but there's a lot of evidence that there used to be water on Mars. So Mars used to have a thicker atmosphere that allowed liquid water. So the atmosphere must have been much thicker in the past. So we find dried riverbeds in this heavily cratered region, so the flows aren't recent. There's also signs of flooding, of water flow around craters and deposits caused by water. So there's craters with like alluvial fans in them. So here are some channels. So you have runoff channels that resemble those on Earth, similar to what you see. Some of these things look like the sort of things you see after flash floods. There's no evidence of a connected river system. So these things are probably due to flash floods. But there's areas that might have been covered in water for long periods of time. And Curiosity found rocks that could only form in water. So this might be an ancient river delta, or it might be something entirely different. And much of the northern hemisphere may have been underwater as an ocean, because it's the lowest altitude. So we found sedimentary rocks that could only form in liquid water, and in fact Curiosity found conglomerate. Conglomerate can only form when there are streams, because it has rounded pebbles that are worn down by being carried through a stream, and then it settles and forms conglomerate. Here are the layered rocks. There's evidence of lakes or oceans that probably existed in the past. We found, hematite in rocks. Hematite only forms in liquid water, and there's evidence of evaporation. Now, there might be a bit of liquid water on Mars today. There have been observed these dark streaks on the side of a crater that appear and then disappear. And it's possibly caused by very briny water with lots of salt in it, melting out of the permafrost and flowing down the sides of the crater. And then, so it's a very salty water that briefly flows down the crater and then evaporates, leaving salty material behind. And we don't have a lot of information about this because we've only seen it with like the orbiting probe, the Mars Reconnaissance Orbiter. There aren't any like none of the landers or rovers are anywhere near this where we've seen this. So there's these gullies that possibly indicate the occasional presence of liquid water, but they're on the edges of certain craters. Now, the real question is, if we found water, the question might be, is there life on Mars, or was there life on Mars? So here, this face on Mars thing is just an optical illusion. Humans are incredibly good at seeing faces where faces aren't, because we're social animals. We have a part of our brain that's designed to identify faces, because that's how we communicate with each other. So we'll turn anything that even vaguely looks like a face into a face, including, you know, power outlets, things like that. This is just an optical illusion. The mind tries to make some sense of the randomness we see. Humans are incredibly good at pattern recognition. And because it was an evolutionary advantage, we'll see patterns that aren't necessarily there. But it's better to see things that might be there than to miss things that are there. And there's similar images of a rat and an iguana. These are just random things on the surface of Mars. They're not evidence of life. There's never been an advanced civilization on Mars. If there has been life on Mars, it was probably just single-celled life. So simple life is a possibility on Mars. It's possible because liquid water once existed. It almost certainly doesn't exist anymore because the surface has been sterilized by UV radiation since the atmosphere went away. Though there might be some life buried deep underground because we keep finding bacteria deep underground on Earth. But it's unlikely. Now, the Viking experiments looked for signs of respiration and absorption of nutrients. The results were negative or inconclusive. There's been no real evidence of any life existing on Mars now, but one of the things people are trying to do is look for fossil life, evidence of past life on Mars. But this is tricky. So there was a big hullabaloo a while ago where they thought they might have found a fossilized bacterium in one of the meteorites that came from Mars, but it might not have actually been a fossilized bacterium. It might have actually come from Earth since it landed. It was generally inconclusive. And so one of the things that people are going to look for is these samples that get brought back from Mars once we finally get things up there, if there is actually anything in them, fossil life, evidence of past life. So why do we concentrate on Mars? The reason we're so interested in Mars is because Mars has conditions in the distant past that were similar to those on Earth. There was liquid water on the surface. And the other places in the solar system that might have a chance of having life are much weirder and much harder to get to. Mars has the advantage of also being relatively close. So future experiments will bring samples back to Earth for more detailed study, and who knows what we'll find. The water exists on Mars today in solid form as ice. There's significant evidence for the existence of liquid water in the past. And experiments testing for life on Mars have all been negative or inconclusive. And the other places we think there might be life in the solar system are all in the outer solar system. They're the moons of various Jovian planets. And they are all like oceans underneath thick layers of ice. So the whole approach is very different. So these are the units of the chapter. So summary, Mercury is tidally locked and in a 3:2 ratio with the sun. Mercury has no atmosphere. Venus has a very dense atmosphere. And the atmosphere of Mars is very thin, but similar in composition to Venus. Mercury has no Maria, but does have extensive intercrater plains and scarps. It's a lot like the moon. Venus is never too far from the sun and it is the brightest object in the sky after the sun and the moon. It has lots of lava domes and shield volcanoes, and we've observed active volcanism on Venus. So the orbiter has observed changes caused by volcanoes, like volcanoes erupting. It's comparable to Earth in mass and radius. It's very similar in size to Earth, and large amounts of carbon dioxide in its atmosphere and closeness to the sun led to a runaway greenhouse effect and a very hot surface. The northern and southern hemispheres of Mars are very different. The south is higher and heavily cratered. The north is lower and relatively flat. And the major features include the Tharsis Bulge, Olympus Mons, and the Valles Marineris. And there's strong evidence for water on Mars in the past, and there's ice on Mars today. Mercury has a very weak remnant magnetic field. Venus has none, probably because it's rotating very slowly. Our best understanding of the process by which magnetic fields for planets forms involves the rotation of the planet. So because Venus is turning so slowly, it has very little magnetic field. Mars has very little magnetic field remaining because it cooled off more. It's colder, and so it has less liquid in it. And neither Venus nor Mars show signs of substantial tectonic activity. So that is that. I don't think I have anything I want to save there. So we have a bit more time, so I'm going to cover a bit on the Jovian planets. Just getting ahead. So the Jovian planets are the outer planets. So Jupiter, Saturn, Uranus, Neptune. And they're quite different than the terrestrial planets. So the Jovian planets, they're all larger than the terrestrial planets. They're primarily composed of ices and gases. The ices include water, ammonia, and methane ices. So out in the outer solar system, it's cold enough that water ice acts like rock. I mean, technically, ice is a mineral. If you study geology, you'll find that ice is like naturally occurring ice on Earth is considered a mineral. And in the outer solar system, it's very cold, big sun in. And so the various ices like water ice, ammonia ice, and methane ice all serve similar functions to rock. So you also get like cryovolcanoes, which erupt water, liquid water. They're much bigger than the terrestrial planets, but they're still tiny compared to the sun. The sun is just enormous. They don't have solid surfaces. We're never going to land on any of the Jovian planets. They have atmospheres that thicken to, they all have like hydrogen and helium atmospheres that as you go down become liquid hydrogen and helium because of the very high pressures. But we can land on their moons, and they all have lots of moons. I think they all have at least a dozen moons. Jupiter has like 90-ish. Saturn has like 120 plus. And then I think we've only discovered about a dozen or so around Uranus and Neptune each. Part of that is because Uranus and Neptune, we just haven't explored as much. So the numbers keep going up for moons because we've put like orbiters around Jupiter and Saturn, and so they can identify all the moons. But Uranus and Neptune have only been visited by space probes once. So the outer planets, they're about 75% hydrogen by mass, about 90% by number, about 24% helium by mass, and then various hydrogen compounds. That's like water, methane, ammonia, and then some rocks, magnesium and iron and stuff. But it's mostly hydrogen and helium for, especially for the for Jupiter and Saturn. Uranus and Neptune have a bit more ice in them. They have slightly different structures. But again, the outer layers are, what you're dealing with is just primarily hydrogen and helium. So Jupiter is the largest planet in the solar system. It's about 11 times the diameter of Earth. It's 318 times the mass of Earth. It's the fastest rotating planet. It rotates every 9 hours and 55 minutes. And it orbits the sun every 11.8 years. It's at a distance of 5.2 AU from the sun. And its average density is about 1.3 grams per cubic centimeter. Just as a comparison, Earth is about 5.5. The terrestrial planets are all like greater than 3, or, the moon is at 3.3. Venus, Mercury is 5.4. Venus is, I think it's 5 point something. I'm not sure off the top of my head. Mars is a little less. But the terrestrial planets are all like above 3. Jupiter is one of the denser of the Jovian planets at 1.3. The Jupiter can be imaged well from Earth, even with a little telescope. It's the biggest planet. It's the closest of the Jovian planets to us. You can see Jupiter with the naked eye, and you can observe it with a telescope and see the Galilean moons. So this is Jupiter with its Galilean moons. I wrote Ganymede, Callisto, I believe. That's the order they are from in distance from Jupiter. The Galilean moons are the moons that Galileo discovered. They're the 4 biggest moons of Jupiter. Ganymede is the biggest moon in the solar system. It's bigger than Mercury. So this is a true color image of Jupiter. This is what Jupiter actually looks like. Lots of reddish browns and paler whites. These are areas, the banding is caused by areas where either material is, clouds are being, material is in the atmosphere is rising up or sinking down. And you can see bands of flow on either side of those. That same thing occurs in Earth's atmosphere. We have going from our equator to the top of Earth, we would have like 3 bands. Jupiter has more because it's spinning faster and it's bigger. But here is the Great Red Spot, massive storm. But if you've heard of like the westerlies or the trade winds, that's the same sort of thing that's going on here. And the lighter areas are where stuff is coming up, and the darker areas is where stuff is sinking down, but I could be backwards on that. So here is an animation of Jupiter rotating. So you can see the whole surface of Jupiter. So if you were actually watching Jupiter, it'd be a lot more active than this because these are all massive like clouds moving around and stuff. but this is a still picture wrapped around. You can see these storms and lots of weather going on. Now, Saturn, the next Jovian planet, is the ring planet. It has the most impressive ring system of all of the Jovian planets. They all have rings. All four of them have rings, but Saturn's are the biggest and most impressive. Jupiter's is barely visible. Neptune's and Uranus's are quite thin and dark. Jupiter's is like a dusty ring. The diameter of Saturn is about 9.4 times the diameter of Earth. Its mass is about 95 times Earth's mass. It rotates in 10 hours and 33 minutes. Its orbital period is 29.5 years. And its 70 major axis is 9.6 astronomical units. And because Saturn is a little smaller and its gravity is a bit weaker, its density is less than Jupiter's. Its composition is very similar, but it's smaller, so it's not squeezed as much by gravity. So its average density is actually less than that of water. It is 0.7 grams per cubic centimeter. So Saturn is the least dense of the planets. So here's a natural color image of Saturn. Saturn has thicker clouds, so they aren't as dramatic looking as the ones on Jupiter. They're just more similar looking in the layers. And then it has the very dramatic rings. This is a Cassini image of Jupiter in true color. Cassini then went on to orbit Saturn. And this is a video about the exploration by Cassini that went out. Cassini was the first orbiter we put around Saturn. We put one around Jupiter before, which was the Galileo probe. And Cassini is still orbiting Saturn. We put a later probe around Jupiter.
And liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
We have a Doppler signature consistent with engine turn on.
Thick atmosphere. It's got flakes of liquid methane. It has something like this is Enceladus, very interesting small moon, because we discovered this liquid water on Enceladus from the ice depth. And that's surprising because Enceladus is only a few hundred kilometers across. It's small. Massive storm. Some of many, many moons of Saturn. Oh, I guess it's not active anymore. Oh, no, over here. Okay, no, but. Yeah, its mission is ended. So Uranus was, so all the planets up to Saturn are visible with your eyes at night. But Uranus was the first planet that was discovered with telescopes. It's too far away to see without a telescope. And Uranus is weird because it lies on its side. Its diameter is about 4 times the diameter of Earth. Its mass is about 14.5 times Earth's mass. The rotation period is 17 hours and 14 minutes. Orbital period is 84 years. Its semi-major axis is 19.2 astronomical units. And it's about the same density as Jupiter, 1.3 grams per cubic centimeter. Uranus and Neptune are very similar to each other. They're about the same size, about the same mass, about the same density. Well, Uranus is tilted on its side and doesn't appear to have an internal heat source as much, so it has less weather. And Uranus and Neptune have a different internal structure than Jupiter and Saturn. They have more ice in their core instead of liquid metallic hydrogen. So Uranus in natural color, note the lack of features. That's because it doesn't seem to have as much of an internal heat source compared to the other Jovian planets, which means it doesn't have as much weather. And the features we see on these gas giants are in the clouds, they're weather. They're patterns of clouds and things. Uranus is just a blue ball. It's blue because of the methane in the atmosphere. Neptune is similarly blue. Neptune was discovered in 1846. It's the most distant planet. Its diameter is about 3.9 times Earth's diameter. Mass is 17.1 times Earth's mass. Its rotation period is 16 hours and 6 minutes. The orbital period is 165 years. Its semi-major axis is 30.1 astronomical units. And it's the densest of the Jovian planets at 1.6 grams per cubic centimeter. It's also very similar to Uranus. So this is what Neptune looks like in natural color. Neptune does have an internal heat source, so it does have has weather. It has some very violent winds, actually. There's the Great Dark Spot, which is a massive storm. Now, every planet has been visited at least once. In fact, they were all visited by Voyager 2. Jupiter and Saturn have had orbiters. Jupiter has had multiple orbiters. So Galileo was an orbiter and a probe, and then Juno was an orbiter. You'll notice that pretty much everybody at least flew by Jupiter. That's because to get to places far out in the solar system, it's convenient to use Jupiter for what's called the gravity assist. You use Jupiter's gravity to give you a kick. Then you don't have to use as much fuel. So Pioneer 10 in December 1973 did a flyby of Jupiter. Pioneer 11 in 1974 did a flyby of Jupiter. Voyager 1 did a flyby of Jupiter in March 1979. Voyager 2 did as well in July 1979. Ulysses in 1992 did a flyby during a gravity assist. Galileo in 1995 was an orbiter and a probe. So that went to Jupiter, orbited Jupiter, dropped the probe into the atmosphere of Jupiter. Cassini did a flyby on the way to Saturn, New Horizons. In 2007, did a flyby during a gravity assist on the way to Pluto. Juno is the current orbiter around Jupiter. Been there since July 2016. Pioneer 11 visited Saturn in 1979, September 1979. Voyager 1 visited in 1980. November 1980, Voyager 2 in August 1981. The Cassini probe orbited since July 2004, something like that. And then it ended its mission in 2018. And Uranus and Neptune were only visited by Voyager 2. So the Voyager 2 craft visited all 4 planets. It's the only craft to visit Uranus and Neptune. The Voyager probes were set out when there was an alignment of all the planets that was discovered that would have allowed a visit of all 4 of the outer planets. So that was sort of the goal of these probes. And then both of those probes, Voyager 1, after visiting Saturn, was sent off into deep space. Voyager 2 visited Uranus and Neptune and was sent off into deep space. Both of those probes are still active, still sending back data. They are in fact outside of the solar system in interstellar space at this point. So you can go online and see the most recent data from the Voyager probes. Though they have issues because they're so far away that they're hard to communicate with, and they're running low on power. But so eventually they'll die, but they're still working. There was a recent need to do software updates on them, because they update them every once in a while to stop using the stuff they don't need to use anymore. This, you know what? I'll show this next time. So we'll stop here. So that's it for today. I'll see you all next time. We'll start talking about the exploration of the outer planets. That's what we're at.
I just asked them.
Oh, sure. Just sign in.
Okay.
So, start with some quick announcements. Worksheets 8 through 12 will be due on the 8th. Homework number 2 is also due on the 8th. Test number 2 will be on the 8th. That's not next week, but the week after on Tuesday. So all the homeworks and the worksheets are due on the 8th. That's Tuesday next week. Additionally, if you have stuff you haven't finished from the last set, homework number 1, a number of people haven't done homework number 1. Various of the worksheets, quizzes from the worksheets. You can always turn them in late. You'll get most of the credit. At least 90% credit. They'll have some penalty for lateness, but it's not going to be terrible. Just wanted to go over that. And the biggest the penalty will be is 10%. So it's always better to turn something in late than not at all. So, continuing on. I am to like come on, go away. Yes. We were discussing the outer planets. Every outer planet has been visited at least once. This is because Voyager 2 visited all 4 of the outer planets. Jupiter and Saturn have been visited more often. Neptune and Uranus have only been visited once. Jupiter and Saturn have been visited more often and have both had orbiters. Jupiter has in fact had 2 orbiters. The Galileo orbiter, which got to Jupiter around 1995, and then lasted until, let me look that up real quick. Yeah, it was there until 2003 when they crashed it in a controlled manner into Jupiter, because that's how you dispose of spacecraft. And then the Juno orbiter, which has been there since 2016 and is still active. And Saturn was visited by a number of craft and had the Cassini orbiter. Which was there until I believe 2018. Okay. And they plunged it into the planet. In 2017, sorry. And the Voyager 2 craft was the only craft to visit all 4 planets, and it's the only craft that's visited Uranus or Neptune. Mainly because it's just hard to get to Uranus and Neptune because they're far away. The Voyager 2 craft the Voyager crafts had this perfect alignment to hit all 4 planets. But lots of crafts that you see here have visited Jupiter, because Jupiter is the gravity of Jupiter can be used to fling things faster. You can pick up some energy from the gravity of Jupiter with what's called the gravity assist. And this is used on gravity assists off various planets are used all the time for various projects in getting things out there, because when you're sending out a spacecraft, you want to use as little fuel as possible, because every bit of fuel you need, you also have to bring extra fuel to carry that fuel. Basically. So if you anywhere you can get an assist is good. So yes, generally they use Jupiter for gravity assists, why Jupiter has been visited so many more times. So like New Horizons here did a flyby of Pluto, but it also did a flyby of Jupiter during the gravity assist. This is the Voyager program. 4 outer planets.
Voyager's grand tour of the 4 giant
The Voyager probes, after visiting the outer planets, continued on into interstellar space and are still sending back data today. Though they've had some issues with communicating with them because they're very far away and eventually they'll run out of power.
Voyager's grand tour of the 4 giant outermost planets marks the conclusion of man's first reconnaissance of the solar system. Jupiter, 2.5 times more massive than all the other planets put together. Saturn, its rings believed to have been born out of the collisions of long-dead moons and asteroids. Uranus, its tranquil atmosphere marred by only a few observable clouds. And Neptune, so distant from the Earth that it's invisible to the naked eye. In the late summer of 1977, 2 unmanned spacecraft, Voyager 1 and 2, lifted off from Cape Canaveral atop Titan Centaur rockets. Traveling uninterrupted through interstellar space, the Voyagers will endure forever, long after everything man has ever built has crumbled into dust. In the event the spacecraft encounter alien intelligence, both Voyagers carry a copper phonograph record, a message, celebrating the sights and sounds of Earth.
And friendly wishes.
These unique discs contain photographs of everyday life, as well as voices, offering greetings in 55 languages. There are also animal noises, the music of Beethoven and Chuck Berry, a baby crying, laughter, rain, and a heartbeat. All of the planets in Voyager's path were in perfect alignment, something that occurs only once every 176 years. The spacecraft were in position to visit all 4 of the outer planets, a grand slam, an interplanetary home run. In March of 1979, nearly 2 years after launch, the Voyagers approached Jupiter, the celestial body that so fascinated Earth's first modern astronomer, Galileo. Passing through the boundary where the supersonic solar wind slams into Jupiter's magnetic field, the spacecraft's instruments recorded a strong bow shock. Named after Jove, the supreme god of Roman mythology, Jupiter is an enormous whirling sphere of turbulent gases, big enough to hold over 1,300 Earths. The Voyagers discovered thin rings of dust encircling the planet, tiny grains containing silicon or carbon, like a fine haze of ash and smoke. Jupiter's atmosphere displays a dazzling variety of alternating patterns. Cold, light-colored zones dominated by ammonia ice crystals in the higher altitudes, and warmer, dark belts of solid sulfurous particles in the lower altitudes. Voyager's cameras afforded scientists spectacular close-up views of the Great Red Spot, a storm 3 times the diameter of Earth raging in Jupiter's atmosphere. Voyager atmospheric scientist Dr. Andrew Ingersoll.
The Great Red Spot is a counterclockwise rotating storm, sort of like a hurricane, that has persisted for over 3 centuries. We were amazed that this spot could survive in the midst of all this turbulent activity.
With at least 16 known moons, Jupiter could well be considered a mini solar system. The Voyagers flew by the 4 largest, finding Callisto pockmarked by craters, Ganymede etched by icy parallel grooves, Europa smooth and icy, and Io glowing a cold and sulfurous red-orange. 9 active volcanoes were found on Io, the first observation of live volcanoes beyond Earth and Venus. These geysers were spewing hot, sulfurous gases 100 miles, high enough to hit a passing satellite. Voyager project scientist Dr. Edward Stone.
If I were to pick one discovery to represent the body of discoveries that Voyagers have made, I would pick the discovery of the volcanoes on Io. These were totally unexpected and really forced us to reconsider our whole concept of the evolution of small moons which are orbiting in the outer solar system.
Pulling away from Jupiter after a joint reconnaissance of more than 6 months, the Voyagers got a healthy boost from Jupiter's orbit and made a beeline for Saturn. Mystifying man since the dawn of history, Saturn bears the name of the mythological god of the harvest, who reigned in the Golden Age. Traveling at more than 55,000 miles per hour, Voyager 1 arrived in November of 1980, only 12 miles off course after an interplanetary journey of more than 1 billion miles. Voyager's instruments found Saturn's atmosphere to be a cold ball of hydrogen and helium gases, racked by huge whirling storms and whipped by winds of up to 1,100 miles per hour. Saturn's magnificent rings, thought to have been the result of collisions between earlier moons and asteroids, consist of thousands of particles, swirling pieces of rock and ice, streaked like the grooves in a phonograph record. Voyager atmospheric scientist Dr. Andrew Ingersoll.
What Voyager discovered was the incredible structure in the rings. Saturn's rings are really composed of countless numbers of particles, ranging from the size of dust and perhaps larger particles the size of houses. These particles are constantly bumping into each other. These grooves are there because the rings are constantly being disturbed by satellites orbiting in with the smaller ring particles themselves.
As the Voyagers swept by, sunlight penetrated, backlighting and brilliantly illuminating the splendor of the rings, like the spokes of a gigantic Catherine wheel. Voyager 1 flew within 2,500 miles of the surface of Saturn's largest moon, Titan. One of only 3 moons in the solar system known to have an atmosphere, Titan may help unlock secrets to the origins of life. Voyager project scientist Dr. Edward Stone.
Certainly one of the more exciting discoveries at Saturn was the atmosphere of Titan. It's an atmosphere which is mainly nitrogen like that here on Earth, but which contains methane, so that the photochemistry going on there today may resemble very strongly that which occurred here on Earth billions of years ago before life evolved.
By swinging around Saturn, after a close-up view of Titan, Voyager 1 was propelled out of the plane of the solar system. It is now traveling toward interstellar space. JPL project manager Norman Haynes.
At this point, with Voyager 1 out of the picture and Voyager 2 capable of going the extra distance, NASA gave us the go-ahead for a grand slam, enabling Voyager 2 to explore the last 2 giants in the solar system, Uranus and Neptune.
First detected in 1781 by English astronomer Sir William Herschel, Uranus, in Greek mythology, is the name for the heavens. 5 years and almost 1 billion miles after leaving Saturn, Voyager 2 reached Uranus in January of 1986. Like all the other planets, Uranus spins like a top, but tipped over on its side. Strangely tilted and off-center, Uranus's magnetic field extends in a bizarre corkscrew tail millions of miles into space. Its magnetic poles are also wildly askew. Voyager 2 discovered 2 new rings. Dark, narrow, thin bands of ice, rock, and dust with particles the size of a fist. Although Voyager 2 discovered 10 new Uranian moons, the most eagerly anticipated event was the close encounter with Miranda, one of the most bizarre moons in our solar system. Close-ups of Miranda revealed a strange and wondrous landscape, including a canyon 12 miles deep. Miranda may have collided with another moon, shattered, and then by the force of its own gravity slowly reassembled itself into this chunk of rock and ice. These digitized photographs are a silent testament to the violent origins of our solar system. Approaching Neptune, after 12 years on the road and another billion miles, Voyager 2 was an exhausted traveler. By August of 1989, Voyager 2 was speeding more than 40,000 miles per hour toward its rendezvous with Neptune, the last stop on its spectacular grand tour of the 4 outer planets. Discovered in 1846, Neptune was named after the mythical Roman god of the sea. The planet appears blue because its methane absorbs most of the red in the spectrum, leaving mostly green and blue. Voyager 2 flew by Neptune only 22 miles off its charted course, and only 1 second off its scheduled flyby time. Skimming only 3,000 miles over the planet's north pole, Voyager found Neptune to be a giant ball of melted rock and ice, cloaked in hydrogen, helium, and methane gases, its atmosphere whipped by winds of up to 700 miles per hour. Voyager flew the closest that any spacecraft has come to one of the outer planets, discovering at least 4 complete rings of ice and rock, 6 new moons, and a great dark spot, a hurricane the size of Earth raging in Neptune's southern hemisphere. Dr. Andrew Ingersoll.
The storm revolves around the planet every 18 hours. And then it rotates around its own axis like a big glob of pizza dough every 16 days.
Largest of Neptune's 8 moons, Triton orbits in an opposite rotation from the planet. Triton was once probably an independent object in orbit around the Sun, until it collided with a moon and was captured by Neptune's gravity. Pockmarked by impact craters and glazed pink by a radiation blitz of methane and nitrogen ices and atmosphere, Triton is the coldest known object in the solar system and one of the most reflective. Utilizing Voyager's digitized photographs of this icy moon, scientists saw jagged mountains, high cliffs, and frozen lakes. The most bizarre discovery on Triton was the presence of icy geysers, some of which are still active, spewing organic particles 100 miles downwind. Dr. Edward Stone.
The Voyager mission to the outer planets has certainly been a journey of a lifetime. Having encountered Triton as the last world we would visit, I don't see how any of the scientists could have been happier.
The success of the Voyager mission concludes man's first reconnaissance of his solar system. Voyager 1 is now heading toward the constellation Hercules. Voyager 2 has set its course for southwest of the constellation Sagittarius. Traveling at 10 miles per second, it is expected to pass 4 light years from Sirius, the brightest star in the heavens, 290,000 years from now. Of the 100 billion stars in the Milky Way galaxy, we barely know one, the Sun and the planets of our solar system. Yet now, courtesy of the Voyagers, we've come to know many strange and wondrous worlds. The cold volcanoes of Io, the tortured terrain of Miranda, the dazzling rings of Saturn, and the icy grandeur of Triton. These alien worlds of sub-zero temperatures, noxious gases, icy volcanoes, and multiple moons are vastly different from our own. Yet they are in many ways the same. We share the same sun. We obey the same physical laws. Yet we are unique. Our planet is the only one we know of that supports life. Voyager's breathtaking views of these other worlds have only made us more keenly aware of our own. Earth is not just another planet. It's ours. It's our home. Perhaps the legacy of Voyager, and all our interplanetary spacecraft, is best expressed in the words of the poet T.S. Eliot. We shall not cease from exploration, and the end of all our exploring will be to arrive where we started and know the place for the first time.
As the Secretary General of the United Nations, I send greetings on behalf of the people of our planet.
Hello from the children of planet Earth.
Bonjour tout le monde. Maelaknya.
Shalom. Hola y saludos a todos. Selamat malam hadirin sekalian.
Konnichiwa. O genki desu ka?
धरती के वासियों की ओर से
So that was a video about Voyager. In summary, the outer Jovian planets have quite different properties from the inner terrestrial planets. Oh, and some facts about Voyager. It's still sending back data. Both Voyager 1 and Voyager 2 are still active. Voyager 1 is about, let's do an imperial. 15.3 billion miles away from Earth, 165 astronomical units, and Voyager 2 is about 12.8 billion miles away from Earth, 137 astronomical units. And they're currently on the other side of the sun from us, I think, looking at the distance from the sun. And right now, light takes 22 hours to reach Voyager 1 and 19 hours, almost 23 hours to reach Voyager 1 and 19 hours to reach Voyager 2. But they still have active instruments. Though they've turned off some of them have failed, stopped working, and they've turned off a bunch of them because they're power hungry, like the camera things. But yes, so the Voyager probes are still out there, still collecting information about interstellar space. The outer Jovian planets have quite different properties from the inner terrestrial planets. Each Jovian planet has its own unique characteristics, and all the Jovian planets have been visited by spacecraft, but to a much smaller extent than Mars or Venus.